Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikmal bin Jeffrey from class AS1201A. My student ID is 2020-754513. Today, I would like to present about modern atomic theory. Okay, for the first is introduction. What is an atom? Atom is a basic unit of matter and defining the structure of the element. 1,000 years ago, the first atomic theorist was the Greek philosopher Leucippus, and his pupil Democritus came up with a general idea. The matter is composed of tiny particles. Democritus reasoned that if a stone were to be cut into smaller and smaller pieces, then it eventually would be so small to be invisible. They call the tiny pieces of atomos. The name atomos is a Greek word which suggests invisible. Democritus believed that the atoms, different in size and shape, were in constant motion in a void, collide with one another, and during this collision, the atom could rebound or stick together. Therefore, change in the matter were not after effect of separation or mix of the atom as they move all the void. Okay, next is John Dalton. John Dalton was born 6 September 1766 in Innisfield, England. He was an English chemist, scientist, and meteorologist. He is best known for implanting of atomic theory in chemistry and color blindness research. During his early career, he identified the hereditary nature of red-green color blindness. In 1803, he revealed the concept of Dalton's law of partial pressure. He was also the first scientist to explain the conduct of atoms in terms of weight measurement in 18 years ago. Dalton died in Manchester, England on 26 July 1844. Okay, this is Dalton atomic theory. John Dalton's fascination with weather and the atmosphere led to him to formally accept that every form of matter, whether solid, liquid, or gas, was also made up of small individual particles. He applied to more abstract theory of matter, which had fallen out of fashion centuries before, by the Greek philosopher Democritus of Abdera, and borrowed the word atomos or atoms to mark the particles. Okay, next is Dalton atomic model. John Dalton suggests that all matter should be composed of very small things he called atoms. This was not a completely new concept, as the ancient Greeks, notable Democritus, had proposed that all matter is composed of small invisible objects. When Dalton proposed electron for his model and the nucleus was unknown, all matter consists of tiny particles called atoms. Atoms are indestructible and unchargeable. Elements are characterized by the weight of their atoms. When elements react, it is their atoms that have combined to form new compound. Okay, next is J.J. Thomson. Sir Joseph John or J.J. Thomson was born on 18 December 1856 in Chatham Hill, England. He went on to attend Trinity College at Cambridge, where he would come to head of Cavendish Laboratory. He was a British physicist and Nobel laureate in physics, credited with the discovery of the electron and the first subatomic particle to be discovered. His discovery into cathode contribute to the electron detection, and he attempted further advance in exploration of atomic structure. Among many accolades, Thomson won 1806 Nobel Prize in Physics. He died on 30 August 1914. Next is J.J. Thomson atomic theory. The discovery of the electron by Thomson changed the way people viewed atom altogether. Atom was considered to be small, stable spheres until the late 19th century. In 1903, Thomson proposed a mode of the atom consisting of positive and negative charge present in equal amounts so that an atom would be electrically neutral. He proposed the atom was a sphere, but the positive and negative charge were embedded within it. Thomson model came to be called the plum pudding model or chocolate chip cookies model. Modern scientists believe that atom consists of a nucleus with positive charge, proton and neutrons, with the nucleus being orbited by negatively charged electron. Yet the model Thomson is significant as it presents the notion that an atom was made up of charged particles. Okay, next is cathode ray tube experiment. During the late 19th century, J.J. Thomson continued to experiment with cathode ray tube. Cathode ray tube are sealed glass tube which have evacuated most of the air form. At one end of the tube, a high voltage is applied to two electrodes, allowing a stream of ion to migrate from the cathode, the negative charged electrode, to the anode, the positive charged electrode. The tube are called cathode ray tube since the cathode originates from the electron beam or cathode ray. Thomson positive two opposite charged electric plates around the cathode ray to test the particle properties. The cathode ray was deflected away from the electric plate charged negatively and toward the plate charged positively. It means that the cathode ray consists of ions that had a negative charge. Thomson also placed two magnets on each side of the wire and noticed the cathode ray was also deflected by the magnetic field. The result of experiment helped Thomson. Thomson determined the mass to charge ratio of the cathode ray particles, which led to a fascinating discovery minus the mass smaller than that of any known atom. Thomson repeated his study using different metals and as electrode component and observed that the cathode ray properties remain stable regardless of what cathode substance they came from. From the evidence, Thomson made the following conclusion. First, the cathode ray is composed of negatively charged particles. Second, the particle must be exist a part of the atom since the mass of particles is only 1 per 2000 the mass of hydrogen atom. Plum pudding, Thomson model of an atom. One of the many scientific models of the atom is described of Thomson atomic model. These were proposed in a year 1904 by J.J. Thomson. Just after the electron were discovered, the atomic nucleus, however, had yet to be identified at the time. So he suggests a model based on known properties that were available at the time. The known properties are atoms are neutrally charged and negatively charged particles called electrons are present in an atom. The atom represents a sphere of positive charge with electrode present within the sphere according to the postulate of Thomson atomic model. The positive and negative charge are equal in magnitude and thus of an atom as a whole has no charge is electrically neutral. The atomic model Thomson resembles both of spherical plum pudding and watermelon. It resembles a plum pudding because much like a sphere plum pudding, the electrode is the model look like the dry fruit trapped in the sphere of positive charge. The model was also compared to a watermelon, as a watermelon red edible portion was compared to the positively charged sphere, and the watermelon's black seed appear identical to the electrons inside the sphere. The atomic model by Thomson did not explain how the positive charge hold the electrons inside the atom. It was also failing to explain the stability of the N atom. The theory failed to mention anything about N atom nucleus. This has been unable to explain Rutherford scattering experiment. Okay, next is Ernest Rutherford. Chemist and scientific Ernest Rutherford was born in Spring Grove, New Zealand on 13 August 1871. A pioneer in nuclear physics and first separate the atom. Rutherford received the Nobel Prize in Chemistry in 1908 for his theory in atomic structure, dubbed the father of the atomic age. On 19 October 1937, in early work, Rutherford discovered the concept of radioactive half-life. The radioactive element radon and differentiate and named alpha and beta. Rutherford died of a strange hernia in Cambridge, England. Okay, next is Rutherford atomic theory. In 1911, Ernest Rutherford disproved the Thomson theory of the atom when he demonstrated the atoms are made entire of empty space. Rutherford found this by shooting alpha rays at a thin layer of gold foil, the helium nuclei. If Thomson's hypothesis was right and the alpha ray would be traveled through the gold atom straight away. Instead, Rutherford found some of nuclei at broad angle being deflected. Rutherford fired positively charged alpha particles at a thin sheet of gold foil. Most pass through the little deflection, but some deflect at large angles. This was only possible if the atom was mostly empty space with the positive charge concentrated in the central the nucleus. He realized positive charge was localized in the nucleus of an atom. Okay, next is gold foil experiment. Subsequent experiments revealed a number of scientific problems with the plum pudding model. To begin with, there was the question of showing that the atom had a uniform positive and background charge, which was known as the Thomson problem. 5 years later, Hans Geiger and Ernest Marsden, who performed a series of experiments using alpha particles and gold foil, would disprove the pattern and experiment with gold foil. In this experiment, Geiger and Marsden used the fluorescent screen to measure the scattering pattern of the alpha particles. If Thomson model were correct, the alpha particle would pass through the atomic structure of the foil unimpeded. Instead, they note that while most of them shoot straight through, some of them were scattered in different directions, some returning in the direction of source. Okay, this diagram shows the gold foil experiment. They has radioactive sample units, beam of alpha particles, lead block shield, zinc sulfate screen. Some alpha particles are deflected. Most alpha particles hit here. Okay, next is Rutherford atomic model. Rutherford conducts some experiments that lead to a charge of ideas around the atom. His new model described the atom as a tiny, positively charged core known as a nucleus, surrounded by lighter, negatively charged electrons. Another way to think of this model was that the atom was seen as a mini solar in which the electron orbit the nucleus like planets orbiting the sun. Sometimes this model is called this same planetary model of the atom. In many ways, the atom Rutherford model is classic model of the atom, although it is no longer regarded as an accurate representation. Rutherford model shows that an atom is mostly empty space with electrons inside, predictable space orbiting a fixed positive charge nucleus. Okay, next is recommendation. The recommendation or more to assumption that we can give after reviewing the modern atomic theory is that maybe the electron is actually a positive charge and proton is negative charge. From the theory that all the great scientists have discovered, we knew that an electron is negative charge and positive charge for the proton. The idea here is maybe those theories can be wrong. According to J.J. Thomson's theory, the electron is negatively charged. He found the evidence from the experiment called cathode ray. Thomson also claimed that overall of the atom is neutrally charged, and that means in an atom there must be positive subatomic particles in an atom. However, what if the charge of the electron proton is positive and negative respectively? It's going to be different. From what we have learned, opposite charge will attract to each other and the same charge will repel. Hence, maybe it's electron and proton in different charge from the Thomson theory. There probably would not be any different. If the proton is actually a negative charge subatomic particle, it would mean that in nucleus would have a negative charge. It is possible for a negative charge particle be a nucleus. It might be positive, but we can see to have an idea to what could possibly happen. And the last one is conclusion. In conclusion, atoms are the smaller particles in element which are made up of proton, neutron, and electrons. Proton and neutron live in the nucleus, which is positive charge in the atom, while electron and the negative charge in the atom move around the nucleus in orbit. Proton and neutron are much bigger than electron. Proton and electron also attract to each other. All the particles are held together by the strong force in the atom. There are 5 atomic theories to show the history of atom, which is John Dalton theory, J.J. Thomson theory, Ernest Rutherford theory, Niels Bohr theory, and lastly Edwin Scottish theory. All of these theories give an idea that all matter is made up from atom. Next, we can also conclude if one proton is added into the atom, the new atom is made. But if a neutron is added into the atom, a new version of atom is made, as the isotope of the atom become heavier than the original one. However, the modern atomic theory has proved by the conducting experiment and doing mathematical calculation that some part of this atomic theory is not right. For example, in John Dalton theory, he concluded atoms are unbreakable or indestructible, but the real matter is atom. What is atom are divisible by using enough energy. Lastly, atom is very important in life. It is bring many benefits to the life, such as nuclear technology that are used for agriculture, food production, medical care, and other. Other than that, oxygen atoms that are used by living things such as human to keep alive, while carbon dioxide (CO2) atom that is released from human are important for plant to do photosynthesis. The H2O, which is water that dominate the earth as they exist in ocean, river, lake, and others, hold an important role in life. They are used widely for drinking water, transportation, cooking, and more. That's all for my presentation. Thank you.